Hey, good afternoon, Math 30s, Math 30-2s. This is your recorded lesson for today, which should be Wednesday, October 23rd. We're starting a new unit, and the unit that we're starting today, according here, is rational expressions and equations. Okay, and I have photocopied the notes for you, or the outline of the notes, so you should have a copy of those. And you should have your new unit outline, which is yellow. And notice that I have put up on the sideboard there and in your square that your next exam will be Thursday, November 7th, which is just the Thursday right before your 4-day weekend in November. So that wraps it up pretty nicely. So what we're doing is rational expressions and equations. And in order to do that, we need to spend 2 or 3 days kind of talking about some basic ideas about rational expressions. So some of this might be review for you, and it shouldn't be too difficult, although we're now sort of, you'll notice we're changing gears, and we're moving into stuff that's way more algebra-based and equation-based than the stuff that we've done in the past in this course so far. So the outcomes that you want to cover, what you should be able to do after the end of today, or the outcome, is determine equivalent forms of rational expressions, and that's limited to numerators and denominators that are monomials and binomials. What you actually need to do, or what today's lesson is about, is talking about non-permissible values. So you need to be able to explain why a given value is non-permissible, not permitted for a given rational expression, and then also be able to determine the non-permissible values for a rational expression. So in terms of talking about rational expressions, we'll review a little bit what a rational number is. And so a rational number is basically, it's a fraction. That's another word for rational number. It's a fraction. So it is a ratio or quotient. Okay, quotient means divide or division. So ratio or quotient of two integers. And so some examples of some rational numbers. We've had some examples in the last unit with probability. We worked with fractions. So 1 over 2, negative 5 over 3, 10 over 5, and so on. Those are rational numbers. So rational expression is the same idea, except that it has variables in it. Okay, so it's not a ratio quotient of two integers. It's a ratio or quotient of two polynomials. So examples of that. Okay, so what a rational expression is, usually it contains variables. Usually we use x, but it doesn't have to be x. Any letter can be a variable. That's what variable means. Variable means that number changes, and everything else in it is a constant. So some examples of some rational expressions are x plus 7 over x plus 8. X minus 3 over x squared plus 1. 7 over 2y minus 3. Those are all examples of rational expressions. And a useful skill that we need to remember or recall or learn again maybe is what's called factoring. And factoring, you're doing factoring when you remove the greatest common factor from all terms. So example 1, we'll review things that we can do to factor in example 1. So what you're trying to do is you're trying to take out the biggest number and biggest letter you can, and then rewrite the expression so that you can also then get back the original expression by just multiplying. So if we write the following expressions in fully factored form, if we look at 8x minus 24, the biggest number that divides both into 8 and 24 is 8. So we can write 8, and then we can't take out any x's because there's only an x in the first term. So this becomes 8 times x minus 3. Okay. And if you went backwards, you could go 8 times x is 8x, 8 times negative 3 is negative 24, and get back what you started with. For part B, we have 10x cubed plus 2x. So the biggest number that divides evenly out of 10 and 2 is 2. And then we have x to the 3 and x. So we can take out an x And then if we divide this by 2x, divide this by 2x, because that's basically what you're doing. Over here, we divided by 8, divided by 8. So 10x cubed divided by 2x is 5x squared. Remember your exponent laws? When you're dividing powers, you subtract the exponents. And 2x divided by 2x is 1. It's not 0, it's 1. Because you need to be able to go backwards. 2 times 5 is 10, x times x squared is x cubed, 2x times 1 is 2x. Okay, C is a little bit more challenging because it's you have to factor that. You have to figure out what you multiplied to get x squared minus 16. And this is called a difference of squares. And a difference of squares always factors to look like this. If both terms are squared, so x squared is a square, 16 is the square of 4, then you're going to have x plus 4 times x minus 4. Because then if you FOIL this, right, if you do first, outer, inner, last, you get back to x squared, you get plus 4x minus 4x, minus 16. Okay, so those cancel out, you get x squared minus 16. And then the last one, D, we can take out an x. So if we divide this by x, divide this by x, we have x times x squared minus 1. Okay, so that's factoring. So in this unit, you're going to need to do a little bit of factoring. And if you don't remember how to do it, don't worry, you're going to get lots of practice doing it. Okay? What we want to do now is just investigate a little bit this notion of this thing that are these things that are called non-permissible values. And we're going to look at 4 different expressions and investigate what their values are given different values of the variable. So if we have the expression 6 divided by x, we want to determine what is the value of the expression when x equals 2. So what that means is take 2 and plug it in where you see x. So 6 divided by 2 is equal to 3. And now we want to do the same thing, but when x equals 0. So if you just, you've probably tried to divide by 0 on your calculator before, but if you go 6 divided by 0 on your calculator, you get you might get something that says error. Okay? And we say this is not defined. Okay? You can't divide by 0. So any number divided by 0, that is not defined. It doesn't exist. It's not 0. It's not infinity. It's not any crazy number. It's not defined. So we're going to look at these 4 rational expressions. And we're going to plug in all these values here for x into each one. Okay, and we're going to see what each of them equals. So we're just going to go across for each value of x. I'm going to try and squish it in here. I don't know that it's going to fit very well, but 6 divided by 3 is 2. 10 times 3 divided by 3 plus 3 gives me 30 divided by 6, which is 5. 8 divided by 3 minus 1 times 3 plus 2 gives me 8 divided by 3 minus 1 is 2. This is where I said it's not going to fit in, but I'll squish a little bit here. So we have 8 over 2 times 5, which is 8 over 10, and that would be 4 over 5, but I've run out of room, so I'm not going to simplify that. And then 3 minus 3 over 3 times 3 minus 2 is 0 over 3 times 1, or 0 over 3, which is just 0. 0 divided by any number is just 0, but any number divided by 0 is undefined. Okay, so we have, so far all of those numbers actually exist. We don't have anything that's undefined. So we're looking to find the not defined values here. 6 over 2 is 3. 10 times 2 divided by 2 plus 3 is 20 over 5, which is 4. 8 over 2 minus 1 times 2 plus 2 is 8 over 4, right? Because 2 minus 1 is 1 times 2 plus 2 is 4. So that's 2. 2 minus 3 over 2 times 2 minus 2 gives me negative 1 over 2 times 0. So this is not defined, this one, because I've got a 0 in there. Because 2 times 0 will just give me 0, right? That is negative 1 over 0 is what we get there. Okay, carrying on. 6 over 1 is just 6. 10 times 6 divided by 6 plus 3. Sorry, 1 Where did I get the 6 from? I guess I'm using the answer from the last one. 10 times 1 divided by 1 plus 3 is 10 over 4, or 5 over 2. 8 times 1 minus 1 divided by 1, 8 divided by 1 minus 1 times 1 plus 2 is 8 over 0 times 3, which is 8 over 0. So this is not defined. And, oh, I've covered that up there. Put this down here. 1 minus 3 over 1 times 1 minus 2 is negative 2 over 1 times negative 1, so that's just 2. 6 over 0 is not defined. 10 times 0 over 0 plus 3 is 0 over 3, or just 0. 8 divided by 0 minus 1 times 0 plus 2 is 8 divided by negative 1 times 2, which is negative 4. And 0 minus 3 divided by 0 times x minus 2 is negative 3 over 0, which is not defined. And if at any time I'm going too fast here, feel free, you guys can stop and start the video as much as you need to fill in what you've missed. So we've got 3 more numbers left to go. 6 divided by negative 1 is negative 6. 10 times negative 1 divided by negative 1 plus 3 is negative 10 over 2, which is negative 5. 8 divided by, let's say, negative 1 minus 1 is negative 2. Negative 1 plus 2 is 1. So that's 8 over negative 2, which is negative 4. And negative 1 minus 3 is negative 4. And then we've got negative 1 times negative 3. So that's negative 4 over 3. That's as much as we can go with that. 6 over negative 2 is negative 3. 10 times negative 2 is negative 20, divided by negative 2 plus 3, which is 1. So that's negative 20. 8 divided by negative 2 minus 1 is negative 3, and negative 2 plus 2 is 0. So this is undefined, or not defined. Sorry, that was the term we were using. And negative 2 minus 3 is negative 5, and then divided by negative 2 times negative 4. So that's negative 5 over 8. That's good like that. And last one, 6 divided by negative 3 is negative 2. Negative 30 divided by 0, so this is not defined. 8 divided by negative 4 times negative 1 is 8 over 4, which is 2. Negative 4, yep, that's right. And then negative 3 minus 3 is negative 6 over negative 3 times negative 5. So that's negative 6 over 15, or negative 2 over 5. Okay, so we've got that done. So now the next part here is we want to complete the table below using the results in B. So we want to list the value or values of x for each of those 4 expressions where it was not defined. So 6 over x was only not defined for when x equals 0. 10x over x plus 3 was not defined when x equaled negative 3. 8 over x minus 1 times x plus 2 was not defined for x equals 1 and for x equals negative 2. And then the last one, x minus 3 divided by x times x minus 2, was not defined for x equals 2 and for x equals 0. So just on the top of the next page, and I'll flip back to this page here too, but it says use the results in C to make a connection between the rational expression and the values of the variable for which the rational expression is not defined. Okay? So there's 2 things going on here. It's not defined for values that make the denominator. equal to 0. So if we go back here, whenever we have a denominator equal to 0, that's when it's not defined. And if you look at this, in 6 minus x, the denominator is x. So we just make the denominator equal to 0, and that's how we get our non-permissible values. This was undefined for x equals -3. So x plus 3 equals 0. We solve for x, we get -3, and so on. So that's what's going on. So if we take a look at this, E, state the values of the value or values of the variable for which the following rational expressions are not defined, then when x minus 6 equals 0, this expression isn't defined. So that means x is not defined, or that expression is not defined when x equals 6. When you have two binomials like this, it's true for either of them. So x plus 5 equals 0. So when x is -5, the denominator is 0. And x minus 9 equals 0. So when x equals 9, the denominator is also equal to 0. So values of the variable that result in the value of a rational expression not being defined are what are called non-permissible values. Okay? Those are non-permissible values. Here, I'm going to highlight that. Use purple. Okay? Non-permissible values. So the non-permissible value of the rational expression x plus 8 divided by x minus 6 is 6. The non-permissible values of the rational expression x divided by x plus 5 times x minus 9 are -5 and 9. Okay? And we can use non-permissible values to find restrictions on variables. Okay? So they can also be called restrictions on variables. For restrictions, what we say is that x is not equal to something, or the variable is not equal to something. So the restriction on the variable for the first rational expression, x plus 8 divided by x minus 6, is x cannot be 6. So for the second expression, x cannot be -5 and x cannot be 9, positive 9. So to find the non-permissible values of a rational expression, you solve an equation where the denominator is equal to 0. Solve the equation where the denominator equals 0. Okay. And you may need to factor. Okay. So if we look at example 2 here. Consider the rational expression x plus 1 divided by 5x squared minus 5. We want to determine the non-permissible values of the rational expression. So as this stands here, we can't do anything with that because that's pretty awkward. So we're going to rewrite this. We have x plus 1, and this is going to be over. We can take out 5x, and then we're left with x minus 1. So we want to solve the equation 5x equals 0, which means x equals 0. So x cannot equal 0. And then x minus 1 equals 0, x equals 1, so that means x cannot equal 1. Those are the restrictions. Non-permissible values are actually the values. The restrictions are when you say which values x cannot equal. It's just the same thing, but you're doing it using a not equals. Okay. Example 3. Determine the non-permissible values in each of the following rational expressions. So all that you're doing in each case is you're just taking the denominator, setting it equal to 2 or to 0, and solving. Okay, this one we could factor. So you could actually write that as -2 times x plus 2, but it doesn't matter here because there's no variable. You want to factor when you have more than one variable, or a variable in each expression. So -2x equals 4, x equals -2. So x cannot equal -2 for that one. We're going to factor this one. So this is going to be p times 4 minus 1. Oh, sorry. Let me fix that. P times 4p minus 1. So p equals 0, and 4p minus 1 equals 0. So that means 4p equals 1, p equals 1 over 4. So the non-permissible values here are p cannot equal 0, and p cannot equal 1 over 4. And we're going to factor. This is a difference of squares, so a minus 7 times a plus 7. Basically, you're taking the square root of the a squared, the square root of the 49, adding it and subtracting it. So a minus 7 equals 0, so a equals 7, and a plus 7 equals 0, so a equals negative 7. So a cannot equal positive or negative 7. And for this last one over here, 2 times x squared plus 4. Okay, so the 2 is okay, and then we have x squared plus 4 equals 0, so x squared equals negative 4, and you can't actually solve that. That's not solvable, because you can't square a number and get a negative number, so this means there are no restrictions. Okay, and last example, example 4. In each case, write a rational expression with a given variable and non-permissible value. So this is just totally anything random. So we're going to use the variable x, and the non-permissible value is 3. So that would maybe be something like 4 divided by x minus 3, because if x is 3, 3 minus 3 would give us 0. The variables a, and the non-permissible values are 0 and 4. So we need to have something like a times, and then we want maybe x minus 4, right? Or sorry, a minus 4. So, and then let's just put a 4 on top, because we're sticking with that. So a equals 0, a minus 4 would give us a equals 0, a equals 4 would give us 0. And the variable is p, the non-permissible value is 1 over 3. So what we want to do is rearrange this. This is kind of what I'm doing here. So this would be a equals 0, a equals 4. Oh, no, that doesn't work for that one. Let's forget that. Okay, so p equals 1 over 3 is a non-permissible value. So we're going to solve this. So 3 times p equals 1. 3p minus 1 is what we want to have on the bottom. So 4 over 3p minus 1. Okay, so that is the lesson for today. Your assignment is just the rest of this on this handout. There's practice questions 1 through 12, and then the answers are there. So there are questions 1 through 12 on this worksheet, or on this handout. Answers are on the back. Okay, have a good afternoon, you guys.